Hey guys, it's Miss Nisha here, and I'm here to go over your Mod 4 dosage calculation with you. Okay, so to prepare for dosage calculation, make sure, for Mod 4 math, make sure that you review syringes. Okay, make sure you know how to tell the difference between a 100 unit syringe and a 50 unit syringe. So for example, here is a 100 unit syringe. Okay, and the question is how many units are in the syringe? So first things first, do you know what each line represents? Okay, how is this syringe even calibrated? If you were unsure, count it. Okay, so let's say we started 80. So from 80 to 90. Okay, so count from 80 to 90. And let's say you were unsure, so you think every line is 1. Well, you're going to count and see if that matches. Okay, so here's 80. All right, so here's the next line. 81, 82, 83, 84. That means that should be 85, but it is not. It's 90. So let's try this again. And now I'm going to try by twos. So there's 80. Okay, that next line, 82, 84, 86, 88, 90. It makes more sense, right? So 100 unit syringes, count by twos. Sorry, my handwriting is horrible. Okay, but you're going to count by twos for this particular syringe. So now, looking at the syringe, how many units are in there? So it may also be hard to tell because of how it's filled in. I always recommend work your way backwards. Okay, so I know this is 80 right here. Okay, so if I count backwards, it's a little bit easier to identify where that line stops. So here's 80. Okay, so then there would be 78. 76 would be the next line, and this would hit the next line, which would be 76 units. Okay, so if you can't tell, go backwards, and I hope that helps. Okay, the next one here, same question, how many units are in this syringe? However, this is a 50 unit syringe, so is it calibrated the same? Is it by twos or is it by ones? If you're unsure, again, count it. Okay, so I'm going to use 25. So here's 25. Okay, the next line, 26, 27, 28, 29, 30. That makes sense, right? That would be 30 there. So these are calibrated by 1. So we're going to say count by ones. Sorry. Count by ones. Okay, so then you know. All right, so now knowing that each line is 1, how many units are in this syringe? So again, if you were unable to tell, count backwards. So here's 25, 24, 23, 22, 21 is where that stops. So that is going to be 21 units. Okay, all right, moving on to the fun stuff. Okay, so for this one here, you are going to read the label. Okay, use this label to calculate and make sure you save your answer because you just might need it somewhere else after this. Okay, so for this one, and with these, please make sure you really read it. Okay, don't just start pulling numbers and calculating, or you're going to end up missing what it's really truly asking you. So for this one, your availables on top. Also, don't get your order and available confused. Okay, order is where it actually says order. Available is the label, but it is on top. Okay, and remember our formula for order over available is the order should be the top number, available on the bottom, quantity on the side if there is a quantity. Okay, so the order reads Tagamet 450 milligrams every 8 hours. The medication has been added to 100 mLs of D5W to infuse over 30 minutes. Your drop factor is 10 GTT per ml, and we want you to round to the nearest whole number. Okay, so all that information, tons of stuff to sort through. The question wants to know how many milliliters of medication must be added to the D5W IV solution. Okay, so a few things are happening here. So first things first, how would I figure out how many mLs of medication need to be added to my D5W? Right, so in order to figure that out, remember when we're doing order over available, okay, times quantity, that last thing that you calculate is the quantity or the mLs. So usually here you have your milligrams or whatever units. Those cancel out, okay? And you're left with your units of ml. So this would be the formula to use, or dimensional analysis, as long as you're ending in mLs. So with all those numbers there, which ones do you really need? Well, again, the order reads Tagamet 450 milligrams. That's my order. Okay. My available, right here on the label. Okay, so here's my 300 milligrams times, remember, quantity is always ml, so times 2 mLs. Okay, that's how that should be set up for this question. Okay, so I'm going to plug that into the calculator. So 450 milligrams divided by 300 milligrams times 2. My answer is 3. So 3 mLs is what I'm left with. Okay, so go back to your question. How many milliliters of medication must be added to the D5W IV solution? Okay, and it was 3. I just want to make sure we understand keywords. Okay, so how many mLs of medication must be added to the D5W IV, right? So you figured out that 3 mLs of this medication needs to be added into your bag, right? So keep that in mind. On the next one, same label, same order. Okay, however, the question now reads, calculate the rate in GTT per minute at which the IV should infuse. So now we're focusing on the actual IV bag. Okay, so again, you're looking at this. This sentence says the medication has been added to 100 mLs of D5W. Remember on the previous slide, you were trying to figure out how much medication to add to that bag. You are actually going to add that. Okay, so here's 100 mLs, but in the previous one, my answer was 3. Okay, so 3 mLs need to be added into that 100 mLs. So that means I should be working with 103 mLs. Okay, because I'm adding it to the bag. Okay, for this one now, because it's asking for GTT, that means I need to use the equation of milliliters divided by any time that you use in minutes times the GTT, or the drop factor, that will always be provided to you. Okay, so that's the formula you're using for this one. So now I have my mLs, which was 103 mLs, because I added the medication into this IV. Okay, it's to infuse over 30 minutes. There's my time in minutes. So 30 minutes times my GTT, which is right here. They gave that to me already. 10 GTT. Okay, sorry, that's sloppy. Okay, and now you're going to solve. So 103 divided by 30 minutes times 10 will give you 34.33333 and so on. Okay, so I'm going to write some of those threes, not all. Okay, and we're just going to draw the line that indicates that that is repeating. Okay, so now it said round to the nearest whole number. So here's my whole number on this side of the decimal, but remember, look behind it. It's a 3. 5 or greater changes it. Since that's a 3, it stays the same. So all of this disappears. You're left with just 34. So your final answer here is 34. Okay. I hope that made sense. But if not, we're going to do another one. Okay. So here's another one. Same concept. Read the label carefully. Pay attention to keywords. Okay. So here you have clindamycin. And your order reads clindamycin 600 milligrams in 100 mLs of D5W over 30 minutes. Your drop factor is 10 GTT per ml, and we're going to round to the nearest whole number when we're done with everything. Your question is, how many milliliters of medication must be added to the D5W IV solution? So again, I only want to figure out how much med has to go into the IV. So on this one, because we're just trying to figure out the mLs, you just need to do order over available, okay? So your order is down here again, and it's 600 milligrams, okay? And we know order divided by available. Available is right here on your label, so another 600 milligrams times 4 ml. So we know that 600 divided by 600 is 1 times 4 is 4. So the answer here would be 4 mLs, right? So you would put that there. So 4 mLs is how much you need to add into your IV bag of D5W. So again, take that answer and bring it on over here. Okay, so remember we're adding 4 mLs. All right, so again now it says calculate the rate in GTT per minute at which the IV should infuse. So again, here's that formula for GTT, milliliters divided by minutes times the GTT. Okay, so now I know 4 mLs needs to be added in, and again I have 100 mLs, so I'm gonna add the 4, so 104 mLs is my starting point. Then I'm going to divide that by the time in minutes, which is 30 minutes. And multiplying it by the GTT, which was 10. I'm going to say GTT. Okay, so let's plug that one in and see what we get. So 104 divided by 30 times 10, and you get 34.6 with a bunch of repeating sixes. Okay, so if I round that to the whole number, again, on this side of my decimal point is the whole number. Behind that is a 6. 5 or greater bumps it up. Okay, so that means that my final answer, when rounded, should be 35. Okay, so 35 GTT per minute is what your answer should be. All right, hopefully this helps in calculating that. Okay, the next concept that you need to practice and go over is milliliters per hour. So this one reads, client with an infusion pump has an order for 4,500 mLs of D5W over 24 hours. Calculate the flow rate for the infusion pump in milliliters per hour and then round to the nearest whole number if needed. Okay, so remember when we see mLs per hour, you can kind of write it like a formula. Okay, and then see what numbers you need and plug them in. In this case, we only have 2 numbers. So we have 4,500 mLs, and we're going to divide that by the hours right here, which is 24 hours. Okay, let me calculate that for you. So 4,500 divided by 24, we're going to get 187.5. Our last set of instructions says round to the nearest whole number. Okay, so that means, again, right here is the whole number. Behind it is a 5. It means it's going to change, and it's going to bump it up. So I should write my final answer as 188 because that 5 changed the 187. Okay, so that is that. Make sure you know how to set it up and calculate. Okay, another fun part is being able to identify if the the percentage is weak or strong. So if you were looking at your patient's ointment and it said 0.1%, is that weaker or stronger than, let's say, 0.5%? So we'll say these two right here, okay? All right. If you did not know, right, you could look at those. We know 0.5 is half, 0.1 is going to be smaller. Another way that you could look at these to kind of get an idea is you can add an extra 0, okay, and I'll bring 0.5 and add an extra 0. Now looking at it, you have 10 and 50, 0.10, 0.50. Which one's larger? 0.50, right? So this one is the stronger one. This one would be the weaker one. You can apply that same rule with all of them here, okay? If I added 0.30, it already fits the format, and you can see which one is which. Okay, so if I rank these in order of weakest to strongest, you would have 1 for the weakest. This one here would be 2, 0.30, and then 0.50 would be the strongest, right? Anytime you see a whole number amongst a bunch of decimals, the whole number is going to be the strongest, okay? And then anytime we have one like this one, where it's 0.025, the further away from the decimal point we get, the weaker it gets. So this one is the weakest, and this one would be the strongest out of all of them listed, okay? Hopefully this helps. All right, next concept. This one is my favorite, Okay, so this one here is about a 4 or 5 part question. Okay, so you use the same label and you're going to answer 1, 2, 3, 4. Sorry, so 4 different questions based on this label. Okay, so the first thing you need to figure out is what is your client's weight in kilograms? So read through it, take your time and read through the order. Okay, our client's weight is 220 pounds, but we need it in kilograms. So remember, 220 divided by 2.2 is how we convert to kilograms. So we're going to get 100 kilograms. Okay, that's one question. And round only if you need to round. The next question, so let's say that was question 1. Here's question 2, 3, and 4. Okay, so for question 2, what is the minimum daily dosage? Okay, so notice this is a range, and the range is 200 to 300 milligrams per kilogram per day. All you need to look at is the 200 to the 300. Okay, so let's write that out so we can really see it. So this is what that looks like, 200 milligrams to 300 milligrams per kilogram per day. Okay, so we want to know what's the minimum daily dosage. Because it said daily dosage, you will have to actually calculate it to find out what they're getting for the day. Okay, so we know here's minimum. This is the lowest out of this range, right? Here's the maximum out of the range. So for number 2, the minimum daily dosage, you would have to calculate 200 milligrams. And since this is per kilogram, multiply. And you have the weight right above us, 100 kilograms. So you're really going to solve it. Okay, so 200 times 100 is 20,000. Okay, so that's the minimum daily dosage according to that range that your patient could receive, right? Question 3 says, what is the maximum daily dosage? So you're going to do the same exact thing, but now we're going to use the maximum number, right? So the maximum number was the 300 there, right? So 300 milligrams times the patient's weight in kilograms, okay? And that's going to give you 30,000 milligrams, okay? And then you're done with that part. So then when you move on to question 4 wants to know, is the order safe? Yes or no? Sure, you could click 1 and take, the 50-50 guess, or you could know how to calculate it, okay, to know for sure, is it safe? So in order to calculate this, notice that question 4 says, is the order safe? So that means focus on the order. So in order to do so, you're going to use this chunk right there. That's it, right? That's all your order, just that. Okay, so the doctor ordered 5.5 grams of Takar, okay, for the patient to take every 6 hours, right? Remember, everything that we've calculated has been daily dosage, so for the day. So first things first, everything we've used so far the recommended amounts has been in milligrams. Your doctor's order is in grams. So first things first, get rid of grams and convert them to milligrams. So here's 5.5 grams, okay? To convert that to milligrams, remember I'm going to write this out real quick. Remember, it goes grams, milligrams, micrograms. If we are going in this direction, sorry, that looks crazy, okay? We are multiplying by 1,000. If we are coming back this way, we are dividing by 1,000. Okay, so because I'm going from grams and I need it in milligrams, I'm going to take 5.5 and multiply by 1,000. Okay, so 5.5 times 1,000 gives me 5,500 or 5,500. So this equals this in milligrams. Okay, so now we have that part. Now I need to look at that. So 5,500 milligrams, and it says that it's given every 6 hours. So remember, when we see every 6 hours, how many times in the day do they actually receive this medication? Because we're looking at daily dosage. So if someone were to receive a medication every 6 hours in a 24-hour period, that means they're going to receive their meds 4 times. Okay? Because 6 times 4 is 24, right? Okay, so you're going to use 4 as the number to calculate. So 5,500 times 4, that means they're getting this amount 4 times a day. They're actually going to receive, for the daily dosage, 22,000. Okay. And it's okay that these sound like really large numbers or this sounds crazy. It's practice math. Okay, it's just math. All right, so 22,000 milligrams. So now here's your answer. You figured out what the order says, what the order really means. Is this number within the range of the recommended daily dosage, right? So you're going to look right here. You're going to go back to 20,000 and 30,000. So does this number fit in between them? If it does, then your answer here is yes. It's safe because it is between 20,000 and 30,000. It's in between their minimum and their maximum. If for some reason you calculate and that number is below 20,000 or above 30,000, then the answer is going to be no. It's not safe because it doesn't fit in the recommended range for that patient. Okay, but in our case, it does fit. It's in between the range, so yes, it is safe. Okay, play this video back, work them out along with the video. Make sure you understand these concepts through and through. And if you need any further help, just reach out to me.